Distance between two skew lines. In this module, you will learn to find the distance between two skew lines. Some lines in the space are neither intersecting nor parallel. This is because they do not lie in the same plane. Such lines which are neither intersecting nor parallel are called skew lines. Every pair of skew lines has a minimum distance between them, which is the length of common perpendicular to the two lines. Consider two lines L1 and L2 in two different planes. Since the lines lie in two different planes, so they are skew lines. Let L1 passes through point A and L2 passes through point B, whose position vectors are vector A1 and vector A2 respectively. Now assume that vector B1 is parallel to the line L1, so that the vector equation of line L1 is given by vector R is equal to vector A1 plus lambda times vector B1, where lambda is some scalar. Similarly, vector B2 is parallel to line L2, so that the vector equation of line L2 is given by vector R is equal to vector A2 plus mu times vector B2, where mu is some scalar. If the shortest distance vector between L1 and L2 is vector PQ, then it is perpendicular to both the lines L1 and L2. Since vectors B1 and B2 are parallel to the lines L1 and L2 respectively, vector PQ is perpendicular to both the vectors B1 and B2. Vectors B1, B2 and PQ form a right-handed system. Thus, vector PQ represents the vector B1 cross vector B2. Now, vector B1 cross vector B2, when divided by its magnitude, gives the unit vector along it, which is represented by n cap. Now, if the magnitude of vector PQ is d, then vector PQ is equal to dn cap, as a vector is completely described by the product of its magnitude and unit vector along it. Let us assume that theta is an angle between vector PQ and vector AB. Then the ratio of magnitudes of vectors PQ and AB is equal to cos theta. This implies that magnitude of vector PQ, that is d, is equal to magnitude of vector AB into cos theta. Also, the dot product of vectors AB and PQ is equal to the product of their magnitudes into cos theta. This further implies that cos theta is equal to dot product of vectors AB and PQ upon products of their magnitudes. In triangle OAB, Applying the triangle law of vector addition, you get vector A2 minus vector A1 is equal to vector AB. Also, vector PQ is equal to D n cap and its magnitude is equal to D. Substituting vector A2 minus vector A1 in place of vector AB, D n cap in place of vector PQ, and D in place of magnitude of vector PQ, you get value of cos theta as D n cap dot vector A2 minus vector A1 whole upon D into magnitude of vector AB. Now, substitute vector B1 cross vector B2 upon magnitude of vector B1 cross vector B2 for n cap. Substituting this value of cos theta in the equation, D is equal to magnitude of vector AB into cos theta, we get the shortest distance D as vector B1 cross vector B2 dot vector A2 minus vector A1 whole upon magnitude of vector. Now if the Cartesian equation of two skew lines is x minus x1 upon A1 is equal to y minus y1 upon B1 is equal to z minus z1 upon C1, and x minus x2 upon A2 is equal to y minus y2 upon B2 is equal to z minus z2 upon C2, then the shortest distance D between the two skew lines is given by the determinant of x2 minus x1, y2 minus y1, z2 minus z1 in the first row, a1, b1, c1 in the second row, and a2, b2, c2 in the third row, whole divided by square root of b1, c2 minus b2, c1 whole square plus c1, a2 minus c2, a1 whole square plus a1, b2 minus a2, b1 whole square. In this module, you have learned that shortest distance between two skew lines with equations vector r is equal to vector a1 plus lambda times vector b1, and vector r is equal to vector a2 plus mu times vector b2 is given by magnitude of vector b1 cross vector b2 dot vector a2 minus vector a1 whole upon magnitude of vector b1 cross vector b2. Shortest distance between two skew lines with equations x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1, and x minus x2 upon a2 is equal to y minus y2 upon b2 is equal to z minus z2 upon c2 is given by determinant of x2 minus x1, y2 minus y1, z2 minus z1 in the first row, a1, b1, c1 in the second row, and a2, b2, c2 in the third row, whole divided by square root of b1, c2 minus b2, c1 whole square plus c1, a2 minus c2, a1 whole square plus a1, b2 minus a2, b1 whole square.